Hello, stellar students. You have been practicing multi-digit multiplication for a long time now, several lessons worth. And today is the moment you've all been waiting for because we're finally going to get to learn the traditional method for multiplication. Or for some of you, it will be a review because I noticed that a lot of students tend to like using the traditional method and have already been practicing it. But for some of you, it'll be new, which is very exciting. The reason that's so exciting is because I think of this as the super shortcut method. So, flashback with me to when we first learned the partitioning rectangles and we were drawing so that you'd have a good visual model of what multiplication looks like in a rectangle. So, that was method number one. Then we learned a shortcut for that, how you could do partial products and just use notation to quickly record the partial products. Well, if that's the shortcut, traditional is the super shortcut. And let me show you what I mean. So first, let's review partial products method. If I look at this problem, 64 times 3, I am going to first do 3 times 4 is 12. And since that's my partial product, I just write it below. And then now I'll find my second partial product, 3 times 6. Well, how dare you? I'm not a 6. I've worked hard to be in the tens place, right? You have to respect the place value when you do partial products. So we have to say 3 times 6d is 180. You with me so far? So I have my two partial products, and I add them up to get 192. Now, the super shortcut. If you do traditional, you can use regrouping to keep place value, to pay place value its proper respect, but then you can just treat each of these as a digit. Let me show you what I mean. So if I do, oh, and this is key. With traditional, you must start in the ones place. Say it with me. You must start in the ones place. I'm serious about that. Otherwise, it's going to be a whole mess because that's where we have to regroup from and build on. So I start 3 times 4 is 12, but this time instead of writing 12 below, I'm going to put down my 2, the ones, and then regroup my tens. And now I can just do 3 times 6 is 18, and I add one more, that 10 I regrouped from before, to get 19 tens, and I record that right next to my 2, and now I have my product, 192. So you got the same answer, just with a different method. And traditional does tend to be the most efficient method. Sometimes you'll like partial products for doing mental math or just if it helps you check your work. But you'll find a lot of mathematicians use the traditional method for speed and efficiency. So now let's look at a 3-digit by 1-digit. And I want you to first try partial products, which you know well. So pause the video and just try this out with the partial products method. Play back when you're ready to see the answer. Okay, so your partial products, you should add 3 times 5 is 15. You should have had 5 times 10 is 50. And 5 times 700, excuse me, is 3,500. And then I could add up those 3 partial products. So you should have gotten 3,565. Give a woohoo if you agree. I'll show my notation. Those were addition. And in partial products, it didn't matter what order I added these products because we know we could have added 50, then 15, then 3,500. Addition is what we call commutative, which means that you can add in any order. Okay, but now let's look at this with the traditional method, the super shortcut. And we are always going to start, you must start where? In the ones place. Okay, so 5 times 3 is 15, but this time I'll write down my ones, regroup my tens, little plus sign up there. Okay, 5 times 1 is 5, plus 1 more is 6. So I write that in my tens place. And then 5 times 7 is 35. So I write that in my hundreds place, or up to thousands place actually. And then I get 3,565. See, my answers match, but it was just a more efficient way to use my traditional method of writing down and regrouping. So decide which method works best for you. You have a really solid foundation now that you've practiced so many different methods of multiplication. You really understand what's going on when you use these different methods.